this is Lakshmi. Welcome to my channel Lakshmi Lucky. Okay, so here we'll discuss one more problem on Riemann sums. Okay, already we did one problem and one more problem also we'll do. Here given one problem. LFP, compute LFP and UFP of function f defined by f of x equal to x square on close interval 0, 1 and p is equal to 0, 1 by 4, 2 by 4, 3 by 4 and 1 has given. Okay, so what has given here? The function is nothing but f of x is equal to x square has given, and the partition is nothing but 0, 1 by 4, 2 by 4, 3 by 4 and 1 has given. So these are the elements lies between 0 to 1 on this interval, this function defined. So here the function is nothing but this partition divides into the interval 0, 1 into sub-intervals. So 0, 1 means so you should take 0, 1 means in between the values partition. How many are there? 5 elements. In between 0 and 1 more 3 elements are there. No, 1 by 4 you should take, 2 by 4, 3 by 4 and this is 4 by 4, that should be is equal to 1. So we are dividing sub-intervals. So first one is nothing but sub-interval 0, 1 by 4, that is I1 we are taking, and 1 by 4, 2 by 4, that is one of the sub-interval. I2 is equal to 1 by 4, 2 by 4 and next 2 by 4, 2 by 4 and 3 by 4, that is nothing but I3. Next sub-interval is nothing but 3 by 4 and 1. Okay, that is I4. So here these are the sub-intervals of the interval 0, 1. Now we'll find the length. Length is nothing but delta 1. I1 length is nothing but 1 by 4 minus 0. 1 by 4 minus 0 is 1 by 4 only, right? No, and I2 length is nothing but here delta 2 is equal to 2 by 4 minus means upper limit minus lower limit, right? No, 1 by 4. 2 by 4 minus 1 by 4 is nothing but 2 minus 1, 1 by 4. Okay, and I3 its length is nothing but delta 3 we are taking upper limit minus lower limit, 3 by 4 minus 2 by 4. 3 minus 2 is 1 by LCM is same, no, by 4, and I4 is also its length is nothing but 1 by 4. 1 minus 3 by 4. 1 minus 3 by 4 is nothing but 4 ones are 4 minus 3 by 4. 4 minus 3 is nothing but 1 by 4. Okay, so we can find the length of each interval is nothing but like this, okay, but length is nothing but same in each interval. Now we'll take the infimum and supremum. Small m1, small m2, m3, m4. These are the infimums. Okay. Small m1 is the infimum on this subinterval. Small m2 is the infimum second interval, and m3 is the subinterval in I3. m4 is the subinterval in I4. Okay. So here infimum is nothing but least. So 0. Okay. That 0 you should substitute. Here we have function f of x is equal to x square has given. This is the increasing function right now on this interval 0, 1. Okay. So this m1 equal to each interval. These elements you should substitute in this function. Then we should get the infimum values as well as supremum values. First I am finding infimum values. First value 0. This is we are substituting in this function. 0 square is 0. Okay. And second is nothing but from the second interval first element 1 by 4 you should substitute in this function. 1 by 4 whole square, 1 square by 4 square. 4 square means 16. That is 1 by 16 we should get. Okay. And m3 from this subinterval first element you should take 2 by 4. 2 by 4 you should substitute in this function whole square, that is 2 square is 4, 4 square is 16. Okay, 4 ones are 4 4s are 16. It should be get cancelled, but we'll keep like that only. Okay, and M4 is nothing but last subinterval, that is first element you should take ma, that is you should substitute again in this function 3 by 4 whole square, that should be is equal 3 square is 9, 4 square is 16. Is it clear? So these are the infimum values in each subintervals. Okay. Similarly, we'll find the supremum values. Upper values you should substitute. Okay. Manam first elements ni ee function lo substitute cheskunte we should get ma infimum values right now, and in this case also I am substituting second value. Upper limit you should substitute from the subinterval first one. 1 by 4 whole square is 1 by 16, and from the second subinterval 2 by 4 you should substitute again in this function. 2 by 4 whole square is 4 by 16, and from the third interval 3 by 4 you should substitute in this function. Okay, 3 by 4 whole square means 9 by 16, and from the last subinterval 1 you should substitute in this function. 1 square is nothing but is equal to 1 only. Okay, so these are the supremums, maximum values from this each intervals. Now by using these infimum and supremum values and length of the intervals, we'll find the LFP and UFP. Okay, so here how many values are there ma? How many subintervals are there? 4 subintervals are there. Okay, so now LFP is nothing but we are defining summation small mr delta r, where r values from 1 to 4. 4 subintervals are there. So that's what you should take ma, 4 r values from 1 to 4 you should take. Okay, so how can we write m equal to r equal to 1, you should substitute here. If r equal to 1 means m1 delta 1 plus r equal to 2 you should substitute in this ma, r equal to 2 means m2 plus m2 delta 2 plus r equal to 3 you should substitute, we should get m3 delta 3 plus r equal to 4 you should substitute ma, m4 delta 4. Is it clear ma? So in this we should substitute the values ma, then we should get the LFP, Riemann sum, lower Riemann sum value we should get. Okay, now m1 is nothing but 0, delta 1 is nothing but what is there, 1 by 4. Okay, delta 1 is nothing but 1 by 4 is there, plus small m2 value what is there ma, 1 by 16, and delta 2 is 1 by 4 is there. Substitute here. M3, small m3 what is there ma, 4 by 16 into delta 3 is 1 by 4 plus small m4 is nothing but 9 by 16 into delta 4 is nothing but also 1 by 4 is there. Okay, that should be is equal to 0 into something is, we should get 0 only, plus 1 into 1 by 16. Okay, 1 by 16 fours are 16 fours are 64 plus here 4 gets cancelled, 1 by 16. R simplification easy రావాలి అని అంటే as it is రాసేసేయండి, తర్వాత క్యాన్సిల్ చేసుకోవచ్చు. ఓకే, 4 by 64 plus 9 by 64. So then after ma LCM is 64. LCM is 64. You should add 1 plus 4 plus 9. 9, 10, 14. 14 by 64. This is the LFP, lower Riemann sum. Okay. Now upper Riemann sum will find UFP. That should be is equal to summation capital MR delta R, where R value from 1 to 4. Okay. Again here also instead of R you should substitute 1 to 4 elements. First I am substituting R equal to 1 in this capital M1 delta 1 plus next I am substituting to capital M2 delta 2. I am substituting now r is equal to 3. Then we can write now M3 delta 3 plus again last 4 is there, r equal to 4, you should substitute here M4 delta 4. Is it clear ma? Now again you should substitute, we have the values no, all the values you should substitute in this. Capital M1 is nothing but what is there ma? 1 by 16 into delta 1 is nothing but 1 by 4 plus M2, capital M2 is 4 by 16 into delta 2 is 1 by 4 plus M3 is nothing but 9 by 16 into delta 3 is 1 by 4 plus M4 is 1 into delta 4 is also 1 by 4. Okay, now you should simplify this. 1 by 16 4s are 64 plus 4 by 64 plus 9 by 64 plus 1 by 4. Okay, so here 9 10 14 14 by 64 plus 1 by 4. LCM you should take ma. 64. 4 16s are 64. So 14 plus 16. Okay. 20 30. 30 by 64. This is the UFP. So we have to find like this ma, lower Riemann sum and upper Riemann sum like this. Okay, very important problems for 4 marks. It will come definitely. Okay, note. Yeah. Now we'll discuss one more theorem, very important theorem. So in this Riemann integration, if f is defined on closed interval a comma b by f of x is equal, k has given, the function is nothing but k. Here k is nothing but constant. Okay, for all here x belongs to closed interval a comma b. That means what? X is nothing but element in between a and b. Okay, and where k is nothing but here constant, we are saying that only no. Now f has given here Riemann integral. F belongs to closed interval a comma b. F belongs to R of closed interval a comma b means f is the Riemann integrable on closed interval a comma b. Okay, and what we need to prove here? Integral a to b f of x dx is equal to k into b minus a. This is we need to prove. First of all, we'll find the lower Riemann sum and upper Riemann sum. By using those, we'll find the Riemann integral. Okay. Now here the statement has given in the exam either like this, or they can give a constant function is Riemann integral. Simply they can give like this also. So you should remember these two statements. Okay, and here definitely in this we need to take the partition, that is p is equal to a is equal to x naught, x1, x2, so on, xr minus 1, so on, xn minus 1, xn is equal to b, right now. So in between we are taking initial to n terms. That initial value is nothing but a and nth term is nothing but b we are taking, because in between a and b we have these elements. Okay, so this is nothing but partition on closed interval a comma b. Then for any subinterval, this is the subinterval in a comma b, because I am saying in between a and b rth terms are coming and nth terms also coming, right now. Rth interval is nothing but in between. This is the subinterval of close interval a comma b. Okay, and where r values from 1 to n terms. So here capital MR and small mr, these two supremum as well as infimum in this rth interval. Okay, already we discussed in the theorem. Okay, now here they had given in the statement the constant infimum means length infimum and supremum in both the cases, because the function is nothing but given constant function k. Okay, that's what here infimum supremum both are same, that is k. Okay, where k is nothing but here constant, from the statement only they have given. Now here we'll find UPF and LPF. UPF or UFP both are same. So UFP is nothing but we can define summation capital MR delta R. Right now capital MR delta R, where R values from 1 to n. Delta R is nothing but what ma? Length of the interval. Length of the interval is what? Here rth interval length we need to take. Rth interval length upper limit minus lower limit. Is it clear? Upper limit is nothing but what is there? XR. Lower limit is XR minus 1. Okay. So XR minus 1. Capital MR as it is you should write. Okay. Now here this is capital MR is nothing but what we are taking? We have here small mr and capital MR. In both the cases constant is k. Okay. So capital MR you should take k. Length of the interval as it is you should write. Here k is constant, so we can take outside of the summation, right now. So k into summation of xr minus 1 we can write here, and k into summation of this total term, because r values from where to where? 1 to n terms. Yes, no? 1 to n terms means here in between a to b. So upper limit minus lower limit. Here xr minus 1 is nothing but equal to b. XR is nothing but b. Substitute in this ma. X equal to 1. R equal to 1 means x1 minus x naught, and r equal to 2 you should substitute, plus x2 minus 1 means x1, plus x3 minus x2, so on. Xn minus 1 xn means n minus xn minus 1 will come. Okay, so here all the terms ma, x1 minus x1 plus x2 minus x2 plus x3 minus x3, so on, all the terms should get cancelled. So what are the remaining terms ma? x0 and xn terms. Okay, so here xn is nothing but here minus is there, xn minus x0, no, xn is nothing but what is there? B, right now, and x0 is a. So that's what here length of the interval b minus a. So k into b minus a, that is the constant value. Okay, so upper Riemann sum is nothing but we are getting k into b minus a. Similarly, we'll find lower Riemann sum. Lower Riemann sum is nothing but my summation small mr delta r. Delta r plus no, length of the interval only, xr minus 1. That should be here. Summation small mr also nothing but what is there ma? Constant k only na. So write here k into xr minus 1. So k is also we can take outside of the summation, into summation xr minus 1. Similarly here r values from 1 to n terms you should substitute, same we should get xn and x0 will be there. So xn is nothing but b, x0 is a. Okay, substitute here k into b minus a. Here also this is the constant term, right now. So what we are getting ma here? UFP and LFP, lower Riemann sum, upper Riemann sum, we are getting the same value, right now, same value. So now we need to find lower and upper Riemann sums are we have. Now by using these two we have to find Riemann integrals, upper Riemann integral as well as lower Riemann integral. Then only we'll get the Riemann integral, right now. Now first we'll find lower Riemann integral. Lower Riemann integral we can define a bar to be f of x dx. That should be is supremum of the set of all those elements of LFP, lower Riemann sum. Okay, where p is nothing but p belongs to phi of close interval a comma b means what? Here p is the partition, set of all partitions on close interval a comma b. Okay, So this is nothing but what we got. Lower Riemann sum is nothing but k into b minus a we got now. So right here k into b minus a. That means this is the lower Riemann integral also. We have k into b minus a. And similarly we can find upper Riemann integral a to b bar f of x dx. This is also by using the definition of upper Riemann integral. We can define infimum of the set of all those elements of UFP, where P is the set of all partitions on closed interval a comma b. Is it right, ma? So here infimum of UFP, where P is the partition of closed interval a comma b. Here we can take k into b minus a, because UFP also we got k into b minus a. That only we are taking. Okay. So here we got upper Riemann, lower Riemann integral k into b minus a. Upper Riemann integral also we have k into b minus a. Both are the same values, no? So therefore both are equal to each other. Lower Riemann integral is nothing but equal to upper Riemann integral. That should be equal to k into b minus a. This means common term we need to take, right? No? That is integral a to b f of x dx is nothing but equal to k into b minus a. This is the Riemann integral. So f belongs to R of closed interval a comma b. If it should be satisfied, these two are equal. Okay, then we can say the given function is nothing but Riemann integral on this interval a comma b. So therefore we can write in the common term integral a to b f of x dx is equal to k into b minus a. This is very important problem. So for 4 marks it will come. Okay.